There are two kinds of quantities, scalar and vector, and the difference between them is very, very easy. Vector quantities have direction, scalar quantities do not have direction. Here's a scalar. All it has is magnitude. That's the amount of the quantity. It's a number, say 5. A vector quantity, however, has that same magnitude, but it also has direction, doesn't it? Now, this kind of comes down to common sense. Using your common sense to look at the quantity and say, just, geez, does that have direction or not? Here's mass, a pile of dirt, 2,000 kilograms. Does that have direction? I mean, does mass move north, south, east, west, left, right, up, or down? No, mass doesn't do that. It just kind of sits there, doesn't it? So, just common sense wise, of course not. Mass does not have direction. It's a scalar quantity. But just as obviously and common sense wise over here, we have a girl walking at velocity, 6 meters per second. You ask the question, looking at that picture, does velocity have direction? Does it go north, south, east, west, left, right, up, or down? Of course it does. In this case, this girl is walking to the right, isn't she? She has direction. She could turn around and go left. So, of course, velocity has direction. It's a vector quantity. And from there on, it's really kind of common sense, you know? Let's take a look at some of the popular quantities and put them in these two areas. You probably haven't done the video yet on displacement, but what that is a change in position during a trip. Let's say you start at home and you walk for a while and you end up 2 kilometers east. Displacement is 2 kilometers and east. We do care about direction. Whereas over here with distance, all we care about is how far you walk. There's no direction there. Mass we saw has no direction. It's a scalar. Velocity obviously does. We saw that. That goes in the vector pile. Time. Now time goes around on a clock, doesn't it? It seems like it may have direction, but ask yourself, does time really go, again, north, south, east, west, up, down, left, or right? It really doesn't. The clock moves, but time does not. It does not have direction. Force is a pretty obvious vector, isn't it? You can push something west or east. You can lift it up or down, then push it down. Sure. Force is a vector, has direction. Acceleration, let's see. Let's just use speeding up. Couldn't you speed up, toward the east or speed up toward the west? Yeah, you could. Acceleration has direction. It's a vector. Temperature. You might be fooled into thinking it has direction because on a thermometer, the liquid inside the thermometer goes up and down, doesn't it? But does that temperature really go north, south, east, or west, etc.? The temperature itself? No. The red liquid in the thermometer might, but no. So the temperature is scalar. So that's all you got to do. You got to use your common sense generally, and you'll figure it out. Does that a quantity have direction? That's just one more thing I want to mention to you, and that is velocity is a bit unique. Remember this? The vector has magnitude, the amount of, and direction. There's a special name for magnitude with velocity. It's the only quantity that has that. So we'll never say the velocity has magnitude and direction. We'll say it has speed and direction. And speed is a magnitude. A couple questions then. Question, does velocity have direction? Well, there's velocity, the whole thing. Does it have direction? Sure it does, right there. Does speed have direction? The speed's right there, isn't it? Direction is not inside of that, is it? No, speed is the magnitude, is the amount of. So, like 6 meters per second. So speed is not. All right, so write down your video code. You may need it. BH1A8, all lowercase. Bye.